we were directly impacted by HIV from the 80s. We were one of the few local companies that joined the fight to stand up and start addressing the stigma and discrimination that is associated with HIV then and today. In the early 2000s, we realized we needed a comprehensive global program that tackled workplace protection for people living with and infected with HIV. So in 2005, we announced a global policy for our employees and their dependents, and then extended that to our communities. Today, we are in the 13th year of the program. It is a fact that this disease disproportionately impacts women and girls. Being a woman, a mother, a physician, that really touches my heart, in fact, breaks my heart today. In Angola and Nigeria, we implemented PMTCD programs to provide comprehensive medical care to our employees and dependents, and I'm gladly to report that Chevron has received no reports of transmission of mother-to-child infection of HIV amongst its employees and dependents from 2005 in Angola and 2001 in Nigeria. Since 2012, Chevron has partnered with PACT to increase AIDS awareness, testing, and counseling across Nigeria's Bayelsa state. More than 53,000 pregnant women have been tested and counseled. More than 294,000 employees have been reached with PMTCD messaging. And 735 people have been trained in state-of-the-art training for approaches and techniques for PMTCD. Since 2008, Chevron has partnered with Global Fund to fight AIDS, tuberculosis, and malaria, and directing 60 millions of funds to programs in West Africa and Asia. Chevron's support of the Global Fund has contributed to 20 million lives saved. Taken together, these results are true promising measure of significant progress that we've made with our partnerships, but in the end, this collaboration is found at a very small level. And you will agree with me, this is the capacity to ensure one mother's dream to cradle a healthy HIV-free child. An important feature of our workplace programs is partnerships with local community organizations in the Bay Area, like San Francisco AIDS Foundation, our community health centers, and Oakland's CAPEP, to help guide and support our efforts. In the recent years, we have expanded our programs to include tuberculosis and malaria. But most importantly, what is structured and what is at the foundation of our programs is to allow us to incorporate new proven biomedical and behavioral interventions. And the founding principles are non-discrimination and avoiding stigma. And yes, we do fight that even today. We are delighted, though, this morning to announce that we have incorporated PrEP into our global HIV workplace program and our community programs as one of the many interventions that will be available to our employees and dependents. We have watched the emergence of data and implementation of PrEP programs at the population level, and we believe and we are confident that this is an appropriate intervention for us to provide. For many employees in the global north, for instance, US and Australia and Europe, this may not represent a major challenge, because I know that there are service providers and insurance programs, but we also have countries that have problems beyond this in providing medication and providing PrEP to the workplaces. And this is where we will put our work to provide access. As a company, we are faced with some unique challenges. For instance, we have staff on rigs. We have people in our marine fleets who are away from families for extended period of time. So we know what we are doing. The question is not whether to provide PrEP, it's how we do it in urban and rural settings so it's reached to the people we want to reach out to. We will continue to work our employees impacted by HIV with our local community partners, and will keep providing culturally appropriate programs and keep them engaged. I am looking forward to the rest of the presentation here with my other panelists on the state of the research and implementation science. And in conclusion, I would like to reaffirm my gratitude to the AIDS community around the world, to all of you here, including the IAS, for helping us do our part in the long-term fight to end AIDS. Thank you for your attention today.
Ladies and gentlemen, please welcome to the stage Deborah Waterhouse, CEO of ViiV Healthcare.
Good morning, everybody. It was about a year ago in Paris that I presented a Positive Action Challenge Prize to two community-based organisations working in Vietnam, which link communities and health facilities together to create stigma and discrimination-free services for key populations. At this time, I want to take the opportunity to thank Owen, Kevin, and the team at the International AIDS Society for our continued collaboration on this critical issue in delivery of healthcare. So thank you again, IAS team, for participating and collaborating with us on this challenge. Today it's my pleasure to announce another set of Positive Action Challenges prize winners, and we had over 100 submissions for this prize, and it's focused on stamping out stigma. Positive Action Challenges recognise and accelerates community-led innovations that are breaking barriers and bottlenecks in the HIV response. The Stamping Out Stigma Challenge incentivises the development of digital innovations that enable better communication between clinics and NGOs in order to increase stigma-free access to sexual and reproductive health and HIV services for key populations. So let's get on to the awards. The first award winner is for UTH, or Youth Plus Tech Plus Health, and this organisation works to advance the health of youth and young adults through technology. The Stamping Out Stigma Challenge Prize will help their Trans Connect app educate and empower HIV-focused healthcare providers to better serve transgender and spectrum youth and young adults. So first of all, I'd just like to welcome Leah to the stage and give my congratulations to Leah Edelson, who's here from YTH to accept the award. Thank you. Congratulations. So let's get on to the second of the two awards we're going to make today. This award goes to the HIV/AIDS Legal Aid Network, which provides free legal assistance to people at risk or living with HIV and their families across Eastern Europe and Central Asia. The Stamping Out Stigma Challenge Prize will help them to develop an online platform that will create much needed information links between service providers and NGOs that support key populations in the region. So again, congratulations to the HIV/AIDS Legal Aid Network, and I'd like to welcome to the stage Alexei Sorokin, who is here to accept the award on behalf of the organisation. Congratulations.
To introduce our first plenary speaker, please welcome to the stage Her Excellency Sandra Granger, First Lady of the Cooperative Republic of Guyana.
Good morning. I'm very happy to be here at AIDS 2018, and it is indeed an honor to co-chair this morning's plenary, featuring a very distinguished lineup of speakers. Our first speaker is Dr. Brad Jones from the United States, and he's going to speak on the newest science in the search for a cure and vaccine. The response to HIV has been ongoing for over 30 years now. This has changed with the advances made that have enabled anyone living with HIV on treatment to live a normal, healthy life. As we gather here this week, we're reminded of all the researchers who have dedicated their lives to working on HIV. They have helped bring about the medical advances that we have seen for those living with HIV. However, those advances must continue until we have a cure and a vaccine. I am delighted to welcome Dr. Brad Jones, Assistant Professor, Infectious Diseases Division of Weill Cornell Medicine, New York, in the US, to tell us about the newest science in the search for a cure and vaccine. Brad has dedicated his career to the study of immune response to HIV.
Thank you very much. Good morning, everyone. It's a privilege to have this opportunity to represent a really global, dedicated community of basic science researchers who will not stop until we have a cure and a vaccine for HIV. I have no conflicts of interest to disclose. Okay, so today this talk is going to be broken down into two parts. I'm going to tell you first about efforts that are being made to try to cure HIV disease in people who are infected, and then we're going to transition and talk about developing vaccines that we hope will help curb the epidemic and stop people from becoming infected. We live in an era where it's possible for current medications to suppress virus, and at least for those who have access and who are able to carefully adhere to their medication, it's possible for a person now to be undetectable and untransmittable. Unfortunately, that's not always the end of the story, because if people stop their therapy, the virus comes back. So to talk about how we might be able to do better than this, I want to borrow from a locally appropriate story of another life-saving but impermanent solution, and that's the story of Little Dutch Boy. And the story goes that the boy sees a small hole in the dam that's protecting his town. He's able to plug that hole with his finger until help can come to repair the dam. So in this metaphor, the HIV reservoir in the person is the water. How are we going to do better than antiretroviral therapy and give the Dutch boy a break? So we can either drain the HIV reservoir, by which we mean eliminate all of the infected cells in a person. That's one solution. The other solution is we can reinforce the dam. So we can strengthen the immune response so that the HIV isn't gone, but it doesn't do any damage. So the first approach is what you probably have heard of, referred to as sterilizing cure, and the second is more of a functional cure or remission. So there are a number of therapeutic strategies that are being pursued right now to try to cure HIV infection, and we can break them up into two categories based on this metaphor. Some approaches, such as kick and kill, are efforts to drain this reservoir. We want to reactivate HIV so that it can be recognized by the immune system and killed. One type of gene therapy aims to delete the HIV DNA out of cells, which is another way of draining that reservoir. A second type of gene therapy aims to make other cells resistant to HIV infection. So this is another way of containing the viral reservoir so that it can't do damage. Vaccines and immunotherapies are another way to try to control HIV. And then a very interesting idea, which is a bit of an outlier here, block and lock. We want to force HIV deeper into latency. And this is kind of like freezing all of the water in that dam so that it can't leak out. So we might need a combination of these different approaches. Maybe we need to drain the reservoir as much as we can, and then reinforce the dam, boost the immune responses to control anything that's left. It makes sense that a smaller HIV reservoir is more easily to be contained by the immune system. So again, to draw on this metaphor, these are the monumental dams that are holding back the ocean and I guess keeping us dry now. Whereas in Canada, where I'm from, these kind of small dams hold back small bodies of water. So if we want to cure HIV, we need to know what size of reservoir we're dealing with, and we need to know when we've had an impact, when we've drained the reservoir to some extent, which sounds easy, but that's actually one of the first challenges that I'm going to talk about today. How do we measure the size of the HIV reservoir? And we can break this into two main approaches. The first are direct measures, where we measure the genetic material of the virus, DNA or RNA, and the viral load test that you might be used to is one example of this. A second type is measurement after reactivating the virus. We put cells in a test tube, stimulate them to produce virus, and then ask how much virus is made and whether this virus is infectious. One of the first surprises in the field was that if we measure the virus using this direct measure and we compare it to the measurement from this viral outgrowth assay, we see that the measures differ by about 1,000 to 1, which is a pretty big difference. So why this discrepancy? Are we dealing with holding back the ocean or holding back a pond here? The answer to this is that a large majority of proviruses are defective in people on ART. So proviruses are the genetic material of the virus. This is the information that the cell needs to make the virus. So I'm going to represent the whole HIV genome as this healthy, intact snake. And I'm going to tell you that only 2% of the HIV genomes in your body look like this. The other 98% are defective, so they're only a part of the HIV genome. They can't produce an infectious virus on their own. So one recent advance is the development of a new technology that allows us to more precisely measure and distinguish these intact versus defective proviruses. Each dot here is a measurement from someone living with HIV. You can see if you measure just the tail of the virus or the head of the virus, you get these very large numbers. But in this new approach, you can measure both together, and you get a much smaller number, which is more representative of the viruses that can reach seed infection, the viruses that we have to worry about. So this is a more selective measurement of intact versus defective proviruses, and it's faster, cheaper, and more scalable than viral outgrowth assays, so it's going to enable more rapid clinical development. So that's one challenge. The other challenge is that the virus persists in many parts of the body. So what do we measure? We like to measure the blood because it's relatively non-invasive to draw blood versus targeting, for example, lymph node follicles where we know that HIV persists at high levels. The lymph node follicle is one important example, but there's other tissues or compartments around the body that might contribute to viral rebound. So if we really want to know the viral reservoir and we want to be able to measure it accurately and know where the virus is coming from, I'm going to propose that we need to think about it in three different dimensions that all interact with each other. What is the composition of the provirus? We just talked about this. Is it defective? Is it intact? What type of cell are we measuring? CD4 cells, macrophages? And where are we measuring those? From the blood, from the lymphoid tissue, or from another site? And if we put all these together, I'm going to propose, this is a theoretical depiction, that we'll see that there's nodes that disproportionately contribute to viral rebound. So maybe this pink globe, for example, are the resting CD4 cells in the lymph node follicle, or maybe they're something else. This is something that's an aspirational goal that I think the field is working towards. I'm going to show you soon how we're getting closer on this. So identifying these nodes is going to help guide our cure strategies, and unfortunately, until we have this full map, we run the risk that measurements in clinical trials might miss an effect or might give us a false negative signal. So a partially effective intervention might target right where we need it to target, for example, but we might have other ineffective interventions that just miss the mark. And until we know exactly what we're targeting, this is going to be a challenge. So the technology I just told you about to measure the intact proviruses improves upon this one dimension, this composition of the provirus, by just measuring the intact HIV proviruses. So this zooms us in on the reservoir that we need to care about. And there's progress being made in these other dimensions as well that I won't have time to go into today, but we're getting closer to this really important goal. The second area of advance that I want to talk to you about today is the role of something called clonal expansion in HIV reservoirs. So we have known for some time that you can clone sheep. What we've learned more recently is that HIV-infected cells actually clone themselves in our bodies. And that's true whether they have defective proviruses or intact proviruses. So we know now that these infected cells proliferate and increase in numbers in our bodies. But this is a bit surprising because we've known for many years now that if you measure the total number of infected cells in the blood, these are not increasing. So how do we have proliferation of some cells, but the total reservoir doesn't increase? It really implies that some infected cells have to be dying off naturally in the bodies of people living with HIV, which is pretty encouraging, I think. And this was shown explicitly in a very recent publication that showed that if you look at different clones of HIV-infected cells, their proportions increase and decrease over time. So these are two clones. At this time point, this one is very numerous and this one is not. And at this later time point, the scenario has reversed itself. So the HIV reservoir is dynamic, even though we've shut down viral replication with antiretroviral therapy. And I think that's very important. One kind of provocative thing that I'm going to suggest from this, and it's a question in the field, not something we necessarily know, is does this mean that the HIV reservoirs can undergo evolution? And now we're talking about the infected cell as the biological unit, not the virus, because we've largely, at least, shut down replication. So what are the requirements for evolution to occur? We need variation in population, which we have between different infected cell clones. We need replication and heritability. Because we know that we have this clonal expansion, we now can check this box very recently. And we need selective pressure, differential rates of cell death. So it was suggested with some nice data a few years ago that these clones might have a proliferative advantage. But I think there's some recent publications suggesting that they might also have some survival advantage or some resistance to being killed, which might be important. And here are some publications from the last few years showing overexpression of some proteins that cause survival in HIV-infected cells, and some results from our group showing that these infected cells are harder to kill when we take them out of the body than we might have expected. So I'd say, again, this is a bit provocative, but it's one of the questions that I think is important that's being asked by the field. So let's take these lessons that we've just gone through and see if they can help us interpret some recent results of clinical trials. We're going to focus on kick and kill. Remember, the idea here is you have a latently infected cell which is induced to express HIV so that the immune system can see it, and then we have something like a killer T cell which kills these infected cells. Here's a cartoon of a killer T cell. Here's a movie in the lab. The cytotoxic T cell in red is going to run around, see an infected cell, grab it, and kill it. And you can see the guts of the cell leaking out there. So they're really appropriately named. They really hunt and kill infected cells in our body, and they're doing this all the time. So we want to harness these killer T cells for kick and kill. And so far, the progress that we have made is a bit mixed. Some clinical trials have shown evidences for in vivo increases in HIV expression. So the kick seems to have worked, at least to some extent, but they have not significantly reduced HIV reservoirs. And there's a number of studies here and also the results of the RIVER study presented at this conference. So the question is, why not? We don't exactly know the answer, but let me propose a few suggestions. First, maybe the kick is just not strong enough to reactivate the reservoir. So going back to our dam analogy, maybe our bucket is just too small. We're never going to drain that whole lake. Maybe the kill was insufficiently strong. I showed you a very effective cytotoxic T cell. They're not all so potent. Here's another one in red. Tries to kill this target cell, but it's kind of pathetic. Looks like it's had a rough night out. And the target cell gets away. So maybe the kill just looks more like this. Maybe we targeted or measured the wrong infected cell population. We've talked about the complexities involved in this, and we don't have a full picture yet. And again, perhaps the reservoir harboring cells are just harder to kill than we might have thought, and we might need to overcome that. So there are a lot of efforts being made to improve on the clinical trials of kick and kill. In the meantime, there's some really encouraging results from a non-human primate model of HIV research that I'd like to share. We have to talk now about antibodies. So they're serving the same role as those killer T cells. Antibodies have a few roles. They can block infection of new cells by the virus. but they can also bind to the surface of infected cells and target those for killing by a type of killer cell similar to the one I just showed you. So that's what they're using in this study. Now, amongst antibodies, we can put a few up on a pedestal here that we call broadly neutralizing antibodies. And what makes these special is that they can bind to a very broad array of HIV. HIV is very variable. These antibodies can deal with that and can see all the different forms of HIV. So in this study, the animals were infected with SHIV, which is a monkey version of HIV, put onto therapy, taken off therapy. If they didn't receive any treatment, the viral load comes back in all of the animals. If they received TLR7, which we think is acting as the kick here probably, then it looks very similar. If they receive just the antibody, seems like there's a bit of a reduction in the viral rebound, but what's most exciting is when the antibody is combined with the TLR7, the kick and the kill, now we see that 5 out of 11 animals didn't rebound at all, and the animals that did rebound do so to a lesser degree, and this work is from Dan Baruch's group. So the question is, will this translate to humans and HIV? And one caveat is that these animals were put on therapy very, very early. Not all people living with HIV are fortunate to start treatment very early, so we need to make sure that we develop strategies that can help those people as well. So take-home messages of part 1, which is cure. Therapies aimed at reducing the viral reservoir and inducing remission are showing promise, but HIV cure remains a long-term goal. And I think more basic science research is needed to improve something as seemingly simple as measuring the reservoir so that we know that we're targeting the reservoir that matters. HIV reservoirs are dynamic. Some cells are proliferating, some cells are dying. If we can understand what's governing these dynamics, then we can improve our strategies to reduce the reservoir. With that, I'll switch and talk about HIV vaccine development, which is really the way that we're going to curb the global epidemic by preventing new people from getting infected. We talked about broadly neutralizing antibodies. Those are important for cure, but they're also potentially very important for vaccine development. There's a number of studies that show, either in mice or in monkeys, if you give the animals these broadly neutralizing antibodies, they're very potently protected from infection. So we have compelling evidence that if we can elicit these antibodies, we will probably have a vaccine that works. So can these be elicited by vaccination? Unfortunately, the answer is not easily. And we might have expected that by seeing that in people who are naturally infected, it takes many years for these antibodies to develop. And when they do develop, they have some unusual features. They have a lot of mutation, and they have a weird shape, a very long, what we call a CDR3 loop, which is an arm of the antibody that might need to reach in and target some vulnerable parts of the virus. At least some of the antibodies have this feature. So we think that to elicit this with a vaccine, we might have to learn more about how these are elicited in natural infection and develop a strategy whereby we lead the immune response down an evolutionary pathway through a series of different immunogens, series of vaccines that help them develop these unusual antibodies. And in recent years, there's been some nice proof of principles in animal studies suggesting that we're on the right path with this. With this slide, we're not going to go through all the details. I can refer you to this review paper. The point I want to make is that this approach is really sophisticated. It uses a number of different animal models, and the immune responses that are elicited are studied using really the most advanced technologies that we have available. Single-cell isolation, deep sequencing, structural technologies. The investigators learn as much as they can about these immune responses, and then they iterate. They go back to the animal models and go around and around until we finally get a vaccine that works. So I think when this does succeed, it's really going to be a triumph of human ingenuity, technology, and persistence. In the meantime, it works in cows. So remember I told you that the broadly neutralizing antibodies have a weird shape. That shape is weird for humans, but it's not that weird for cows. It's kind of a normal shape for a cow antibody. So the investigators thought if they take their best vaccine and immunize cows, maybe they'll be able to elicit these special broadly neutralizing antibodies. And what the data show is that that's the case. In black, this is the breadth of neutralization against different viruses, and we get close to 100%. So what this suggests is that efforts that focus on getting human antibodies to have that weird shape is probably somewhere we should focus at least part of our efforts for vaccines. Broadly neutralizing antibodies are promising, but they're not the only approach that's being pursued for HIV vaccines. And you probably saw some of these recent very promising headlines in the news. And these are based on an Ad26 vaccine approach. What's really interesting about this study is that the team is able to vaccinate non-human primates and humans in parallel with closely matched vaccines. They can then study the immune responses using very similar assays and compare them to each other. The animals are then challenged with the monkey version of HIV called SHIV. Of course, the humans are not. But we see that there's 67% protection from infection in the monkeys, so it looked pretty effective. We can compare the immune responses in the humans in blue with the monkeys, and whether we look at antibodies or T cells, we can see they're pretty similar. So this looks encouraging. And the question is, this protected the monkeys, will this protect humans from infections? And to test this, the team is moving it forward into a phase 2b efficacy study in 2,600 women in Africa, and we can all hope that, that this will show efficacy. So take-home messages for part 2. Diverse approaches are in early phase development for HIV vaccines. I only had time to talk about a few of these, but there are others as well. The elicitation of broadly neutralizing antibodies is being pursued through iterative evaluation of engineered antigens. And proof of principle has been established in preclinical models, animal models, for many of the strategies aimed at eliciting broadly neutralizing antibodies. This Ad26-based vaccine showed very similar immune responses in monkeys and humans. It protected the monkeys from infection with SHIV. Will it protect humans from HIV? And we'll have to wait a few years to find out. But instead of leaving you on that cliffhanger, I wanted to leave you with some thoughts that I find inspiring, which is how tragic past epidemics can sow the seeds for future cures that well outlive the pandemic. We have one case of HIV cure to date, and that is the case of Mr. Timothy Ray Brown, who's in the audience. How was this cure achieved? Through a bone marrow transplantation, which is too risky and toxic to be an alternative to antiretroviral therapy, but which has inspired us all by showing that a cure is possible. An important part of this was a mutation that we call CCR5 delta 32 that makes cells resistant to HIV. So where did this mutation come from? What's clear is that it was selected by some past epidemic which caused a lot of death and a lot of suffering in its time. We think it might be the plague, it might be smallpox, it's not clear. But from this past tragedy, the seeds of discovery and of cure have drifted forward into the future until they were found by basic scientists and implemented by a pioneering clinician and a brave participant. Through biomedical research in close partnership with people living with HIV and our clinical collaborators, we are now sowing the seeds of discovery on a scale that is completely unprecedented. We can already point to examples of where discoveries in HIV have helped to save lives in other conditions. The first demonstration of a role for a molecule called PD-1 in the human immune system was from these studies in HIV, thanks to the generosity of people living with HIV who donated samples. And this therapy is now saving lives of people with cancer, really revolutionizing cancer treatment. So we need to focus our efforts on coming up with cures to help people living with HIV now, and on vaccines to prevent new people from becoming infected and to curb the epidemic. We also need to focus on comorbidities, especially tuberculosis, which is still the leading cause of death of people living with HIV. But at the same time, I hope that we can keep in mind that the seeds of the discoveries that we're sowing now are going to drift forward into the future, and they are going to be the seeds of cures for conditions long after this HIV epidemic has been brought to a close. And that will be one of the enduring legacies of this special community that we've built, and it will arise from the very special generosity of people living with HIV, including those who continue to participate in research long after they themselves are healthy, people like this man, and like so many of you who I've had the honor of speaking to today. With that, I'll wrap up and thank all the study participants. as well as mentors and others who have helped me put together this talk, in particular Sharon Lewin, Doug Nixon, and Trip Gulick. Thank you very much.
To introduce our next plenary speakers, please welcome back Her Excellency Sandra Granger.
Thank you, Brad, for a very interesting talk on the work being done in vaccine and cure research. For people living with HIV, ARVs have transformed HIV from a deadly disease into a manageable one. We have seen how in the Caribbean, access to treatment has ensured that 7 of our states have been certified as eliminating the transmission from mother to child. It is therefore fitting that I introduce to you someone who is a past president of the International AIDS Society and who has been in the trenches in the battle against HIV since 1982. That is Dr. Pedro Can, Professor of Infectious Diseases at the Buenos Aires University Medical School, Argentina. Thank you, Pedro.
Good morning. Thank you, Sandra, for your kind introduction. I would like first to acknowledge and really be very grateful to the organizers for inviting me to give this plenary session. These are my disclosures, and I would like to start with acknowledging all the people that provide me with slides and ideas to make this presentation possible. And in particular, a special recognition to the people living with HIV who have generously participated in all the clinical trials reviewed for this presentation. The outline of my talk is, as you can see here. I will revisit why are we using INSTIs in first line, second and third line, what is the potential role in mono and dual therapy, a brief mention to long-acting formulations for treatment and PrEP, safety, special populations, concerns and data gap, access, pricing and programmatic challenges, all in the next 25 minutes. So, starting with why are we using integrase inhibitors in first line? As you may remember, efavirenz was for a long time the undefeated drug. Together with FTC and another nucleoside, or 3TC and another nucleoside, no combination was better, until integrase inhibitors came across. Raltegravir showed superiority at 5 years, dolutegravir did so at 48 weeks, even rilpivirine in patients with less than 100,000 copies did so, and on top of that, efavirenz charges a little backpack with CNS side effects, increased suicidality as has been reported, and some lipid disorders. But more important than that is what you see in the other part of the slide, that is the increase in resistance rate that we see in some regions, namely East Africa, South Africa, and Latin America, in which we are surpassing the 10% threshold, and this makes the selection of efavirenz in first line in the context of countries that don't have genotyping at baseline quite risky. We have other non-nucleosides in first line. Rilpivirine, as I said, is only limited for less than 100,000 copies. And in the next future, we will have doravirine, which has shown to be non-inferior to efavirenz and darunavir, ritonavir, but is not licensed so far. What about PIs? PIs have several advantages. They have a high potency, high genetic barrier, they are durable, and we even have now a new fixed-dose combination of TAF, FTC, and darunavir, ritonavir. But we also see several disadvantages in terms of drug-drug interactions, tolerability and side effect issues, impacting in comorbidities, and metabolic side effects with increasing cardiovascular risk. So, nowadays we have raltegravir, elbaitegravir, dolutegravir, and bictegravir that obviously have to be used in combination with other antiretrovirals that have been approved by several agencies. Integrase inhibitors are now listed as the preferred option for treatment-naive patients in several antiretroviral guidelines, and really it's a good news that now WHO in the 2018 update has included also integrase inhibitors as drugs for first line. Why is this? This is based on efficacy, rapid viral suppression, tolerability, genetic barrier, CD4 recovery, and lower rate of treatment discontinuation. The story started in 2007 when raltegravir was launched, and then after that we saw coming elbaitegravir combined first with tenofovir and later on with TAF, dolutegravir as a solo drug or combined with abacavir 3DC, bictegravir After that, we saw raltegravir in a new formulation, QD, and the approval of the first fixed-dose combination of two drugs, dolutegravir and rilpivirine, lately in 2018. So why, again, is the question, are we using this drug in first line? Talking about potency, you can see in this graph a comparison of the activities of the different classes. And in the orange box that you can see, there are the four integrase inhibitors with a potency in monotherapy of about 2 logs that has not been matched by any other class. So in treatment-naive patients, there are trials that shows us that this is true. Raltegravir has been shown to be non-inferior to efavirenz, equivalent to atazanavir and darunavir-ritonavir. We have now a Q dosing available, which has been shown to be non-inferior to raltegravir BID. Elbaitegravir has been shown to be non-inferior to efavirenz and superior to atazanavir-ritonavir in women. Dolutegravir has been shown to be non-inferior to raltegravir and superior to efavirenz, darunavir-ritonavir, and atazanavir-ritonavir. And lately, bictegravir has shown to be non-inferior to dolutegravir. What about switch? I give you here 2 examples of many trials that you can see in the literature. One is with dolutegravir, the other one is bictegravir. The signs are very similar. People without baseline resistance that are undetectable for at least 6 months, that were switched or were randomized either to switch to the integrase inhibitor-based therapy or to continue with the ongoing treatment. And as you can see, results are very similar with no treatment emergent resistant mutations either with dolutegravir or with bictegravir. Lipid parameters significantly improved, and yes, you see a median EGFR decreased with switch, but this is not a true renal injury. This is just the effect on the tubular transporters that you see with dolutegravir and bictegravir in the first week of treatment, and it doesn't mean that you have renal insufficiency. What about second line? We have seen the results of the Downing study in which the standard of care at that time for second line, that was lopinavir-ritonavir in the WHO guidance, was compared with dolutegravir, obviously in both cases combined with 2 nucleosides. And as you can see, clearly dolutegravir outperformed lopinavir-ritonavir as a second line regimen. When we go to third line, the ACTG 5288 in third line showed that the combination of raltegravir plus darunavir-ritonavir plus minus nucleoside plus minus etravirine in the different strata that I don't have time to explain here, but believe me that the different groups achieved from 74 to 100% viral load below 200 copies in a population that has failed 2 classes, non-nucleosides and protease inhibitors. So again, here we see a nice role for integrase inhibitors. What about integrase inhibitors monotherapy? Well, this has only been tested with dolutegravir. We have seen mixed results in regards to efficacy, but the bad news is that we have a high rate of resistance selection in the integrase gene in the case of virological failure. Resistant mutations go from the 92 to the 263, among others, and this is really very discouraging in terms of continuing trying dolutegravir monotherapy. I think that dolutegravir monotherapy should not be used for initial therapy or as a simplification strategy, and I'm not so sure that it's worthwhile to continue exploring this strategy in clinical trials. Regarding dual therapy, we have several trials in switch or maintenance, most of them with dolutegravir, one of them at the bottom with raltegravir, and 3 trials that explored dolutegravir plus 3TC as initial therapy. We started with a parallel study showing at 48 and 96 weeks that around 90% of the patients achieved the primary endpoint of being less than 50 copies at this time. And the ACTG 5353 took, instead of 20 as we did, they took 120 patients with a higher threshold of 500,000 copies. We did it with 100,000, and they were able to show that the results, around 90% again at week 24, were not different in people with high or with low viral load. I had yesterday the opportunity to present the results of the Gemini trials, Gemini 1 and Gemini 2, with more than 1,400 patients included, that showed non-inferiority for the strategy of dolutegravir 3TC when compared to dolutegravir plus tenofovir FTC at 48 weeks, and we will continue the study until week 144 in order to establish if there's durability of this strategy. What about another combination, dolutegravir and rilpivirine, as you know, has been approved as a fixed-dose combination by the FDA and other agencies, and this was tested in a study in which patients were randomized either to continue the ongoing HEART or to switch to this fixed-dose combination of dolutegravir plus rilpivirine, and you don't need to be a statistician to understand that the results are exactly the same. What about long-acting integrase inhibitors? Well, we have cabotegravir that can be given orally, rilpivirine can be given orally, but also in intramuscular. And in the latter studies, we see here, particularly in the latter two, that when you compare the oral formulation versus the intramuscular application of those drugs, either every 4 weeks or even better, every 8 weeks, the results are really very encouraging, and now there are a couple of trials that are moving forward in order to establish definitely if this is a strategy that we can pursue and really change the treatment paradigm for many of our patients. What about pre-exposure prophylaxis? We have 2 large trials ongoing. HPTN 083 is exploring the strategy of pre-exposure prophylaxis comparing tenofovir FTC with cabotegravir in high-risk MSMs and transgender women. HPTN 084 is doing so in women. And in both cases, you will see that there are different stages, and the third step is when patient goes out of the trial for any reason or just finishes the trial, they will be provided with 1 year, at least 1 year, of tenofovir FTC. Why is that? Because this drug has a very long half-life, and this could imply a long tail after discontinuation. So in order to avoid fading concentrations of cabotegravir that might seed resistance, so the patients will be offered to receive tenofovir and FTC for 1 year more. We have a lot of pending questions, concerns, and research gaps. Namely, what I am going to briefly mention is drug-drug interactions, tuberculosis, safety in pregnant women and children, resistance in real life, side effects, and immune reconstitution inflammatory syndrome. Really, I can say that at least 3 out of the 4 integrase inhibitors are very few drug interactions. Raltegravir is the cleanest one, in which you only have to be concerned with the use of rifampin. So you cannot use the new formulation of raltegravir once a day. With rifampin, you have to use the classic formulation for 100 milligrams twice a day. Dolutegravir can be used, but you need to duplicate the dose. You need to use rifampin 50 milligrams BID. Bictegravir, unfortunately, cannot be used with rifampin, and all regimes are sensible to the use of polyvalent cation-containing supplements, including antacids. So you need to take care of that and tell your patients not to mix this type of cation-containing supplements with your integrase inhibitor. So we have 2 studies that explored the use of integrase inhibitors with rifampin. The first one is the REFLECT study that you know very well, in which 400 milligrams BID and 800 milligrams BID of raltegravir were tested against efavirenz, and the results were pretty similar among the 3 arms. The second study is an inspiring study in which dolutegravir was tested, and as you can see, in patients treated with rifampin, dolutegravir achieved around 75% efficacy. Efavirenz was a little bit better numerically, but the numbers don't allow to do a non-inferiority conclusion. So 75% is the result that I am quoting. Unfortunately for bictegravir, the attempt of duplicating the dose failed, as we heard from Dr. Custodio at last CROI, because the C-trough decreased by 80%. So there are some research questions still pending regarding integrase inhibitors and tuberculosis. How would the BID dosing of raltegravir or dolutegravir impact adherence if a patient is receiving a single tablet tuberculosis regimen? What about drug-drug interactions with the multi-drug resistant TB drug regimens, namely bedaquiline, delaminate, and so on? What would be the efficacy of the new rifampicin-based TB prevention regimens when are co-administered with integrase inhibitors? We don't know the answer yet. Going to pregnant women and children, we have seen the extraordinary work by the CEPAMO group, and we heard from Rebecca Sachs at IAS last year that really they didn't found initially any difference between the dolutegravir-treated women versus the efavirenz-treated women, both in terms of adverse events or severe adverse events. But in the box you can see that there were a small number of first trimester ART exposures. So when I was preparing this talk, I went to the DHHS website, and the arrows is pointing your attention to the date. It was May 11, 2018, and what you could read at that time was that raltegravir was the recommended preferred agent, that elbiteragravir was not recommended, dolutegravir was considered an alternative agent, and for bictegravir there were no data available. Just 1 week later, we saw the safety signal of 4 cases of NTDs reported in Botswana out of 426 periconceptual exposures. As you can see here, several agencies, WHO, DHHS, EMA, PEPFAR, and Beef Healthcare released statements about caution needed when you treat women in reproductive age with dolutegravir. Good news, we saw yesterday, now the denominator has increased from 426 to 596, and we still have 4 cases. It's still, instead of being 0.94%, it's now 0.67%, but it's still higher than the expected rate of NTDs at the population level, which is 0.1%. But we need then to see more data in order to have a larger denominator and see if this phenomena is true or not. You know, this is not the first time we are concerned about the potential relationship with antiretroviral drugs. Look at this, what I am showing you, when the FDA in 2005 downgraded the antiviral efavirenz pregnancy to pregnancy category D. Based on what? On 4 retrospective cases that were reported of neural tube defects. It took 8 years until we realized that this was not a causal relationship. I'm not saying that this is the case with dolutegravir. I'm just saying we need to be cautious in interpreting the first signals we have seen in regards to this drug. So what to do? We need to be cautious. Is this relationship true, or is it just a coincidence? If this is true, what are the implications for other drugs in class? Are other factors involved, for instance, folic acid deficiency? We need more data from different registries focusing on periconceptual exposure to dolutegravir. And let me quote what FDA says. Providers should weigh the benefits and risks of dolutegravir when prescribing IRBs to women of childbearing age. Alternative IRBs should be considered. If the decision is made to use dolutegravir in women of childbearing age, healthcare professionals should reinforce the consistent use of effective birth control. WHO tells us that dolutegravir is a potent, important drug to reduce mother-to-child transmission. Females in childbearing age can receive dolutegravir with consistent and reliable contraception. But counseling does not avoid unintended pregnancies by itself. If we tell this to women, we need to provide free anticonception for women. Programmatic decisions should balance the cost-benefit of affecting the dolutegravir rollout in countries with high HIV burden. Also, equity in access has to be considered. Be reminded of the 10% resistance on efavirenz, so we need to weigh cost and benefit of the decisions. Women need to be informed about the pros and cons of the different options and have the right to make informed choices. We have learned from the community nothing about us without us, and I want to say nothing about women without women. Regarding children, the new, I show you here 2 different sets of guidelines. If you look at DHHS, you will see that raltegravir, elbiteragravir, and dolutegravir are among the preferred drugs, and the indication varies according to the drug, age of the kid, and weight. The public health approach from WHO is recommending dolutegravir in first line and second line, and also as part of a third line regimen, with an alternative for raltegravir for children that do not qualify for receiving dolutegravir. What about resistance? Really very low rate of emergence resistance to integrase inhibitors in clinical trials in treatment-naive patients. As you can see, with raltegravir and elbiteragravir, you have up to 2.4% resistance. No resistance so far has been shown in any clinical trial in naive patients for dolutegravir or for bictegravir. Research questions pending is how relevant are some of the mutations, like the 230 and the 263, particularly those that have been selected in dolutegravir monotherapy studies. A main question is, for patients failing a non-nucleoside-based regime, is it safe to switch to integrase inhibitors without a resistant test? In countries where plasma viral load is not regularly available, how risky is to promote massive switches to dolutegravir, which could include compromised backbones? Regarding tolerability, these drugs are extremely very well tolerated. In the upper panel, you see the comparison between dolutegravir and raltegravir, dolutegravir and bictegravir, and so on. And you can see that really the discontinuations based on toxicity or tolerability issues are very low. And no doubt about that, when you go to the lower part of the slide, you see that in the comparison with protease inhibitors and also with non-nucleosides, in any comparison, the integrase inhibitors have a more favorable tolerability and toxicity profile. Last year, we heard about two cohorts telling us that the risk of immune reconstitution inflammatory syndrome was twice as much when compared when you use integrase inhibitors compared to regimes without them. Fortunately, we have now three randomized clinical trials in which this was not the case. The reality trial included children and adults with less than 100 CD4s. The optimal trial did so with people with less than 200 CD4s, and the inspiring study that explored dolutegravir versus efavirenz when combined with rifampin. In none of those cases, an increase of iris was found. And let me show you some results of the reality trial, in which you can see the green dots and the orange dots are showing us that with raltegravir or without raltegravir, there's no difference. And the most concerning ones that are in the box, the TB-related iris and the cryptococcal-related iris, show no difference when you use integrase inhibitors. So it seems that we can use safely integrase inhibitors even in patients with low CD4s. Coming to the last part of my talk, let me show you the slide that has been generously provided by Medicines Patent Pool, in which you can see that in August 2013, dolutegravir was approved by the US FDA. Just 3 years later, WHO included dolutegravir in first line, at that time as an alternative and now as preferred drug. And in September 2017, several partners announced the price of $75 per patient year for the TLD combination. So this is really unprecedented in terms of having the approval of a drug and putting it in, close to the needs of the patients in the most in need countries. So this is a graph from WHO, and as you can see, the green color, the dark green, is showing us the countries in which dolutegravir rollout has already been started. Lighter green means that those countries are in process to do so. So as we can see, almost 51% of low and middle income countries are making shifts to dolutegravir-containing regimens. It's also true that in some middle-income countries that do not qualify for the low price of dolutegravir, then other integrase inhibitors are also being considered in first line, and there is a kind of tender in terms of cost, because cost is a major driver for middle-income countries. You know, middle-income countries don't qualify as rich countries, but they also don't qualify for low prices. So, here are some examples from a recently released publication in the Lancet. And you can see countries like Botswana, Brazil, Kenya, Nigeria, and Uganda. And you can see here the different costs that those countries are paying, going from almost $40 to almost $500 in the case of Brazil. Good news are that Brazil has now over 112,000 patients on dolutegravir, and South Africa is planning to have 5 million by the end of 2019. So access is coming as we speak. Is this cost effective? I've seen a very interesting paper by Andrew Phillips and co-workers that shows us that at any resistance rate to efavirenz, we see cost effectiveness in the switch from efavirenz-based therapies to dolutegravir-based therapies. Obviously, the higher the rate of resistance, the higher the urgency to do the switch, because cost effectiveness will be higher. In another paper published by Marco Victoria and co-workers, there is a statement that I think we need to keep in the back of our minds. In low and middle income countries, only 50% of the patients have access to regular viral load testing, and genotypic resistance is rarely performed. There is currently no clinical data to support switching patients from tenofovir 3TC efavirenz directly to tenofovir 3TC dolutegravir if the viral load is either detectable or unknown. A very nice paper from the Caprisa group was recently published doing a kind of summary of pending questions and making my life easier just taking a photograph of this paper. And as you can see, the headlines are safety and other issues that I forgot my glasses, but I can tell you probably from here. Monitoring effectiveness, drug interactions, HIV drug resistance, implication for second-line art, and cost effectiveness. So these are the main issues that we need to take in account. There are pending questions, and we need desperately implementation research, not to stop the rollout, but to make the rollout more effective. So in conclusion, we are moving towards the integrase world, and integrase inhibitors are non-inferior or even superior to non-nucleoside and PI-based regimens in naive, biological suppressed, and viremic patients. We have 4 options available. Differences are based on experience, STR availability, DDIs, tolerability, genetic barrier, and affordability. Resistance seems to be not a major issue so far. Integrase inhibitors are shown to be effective as anchor drugs in dual therapy regimens, and durability still remains as a question mark. They are definitely not recommended as monotherapy. DDI and adherence are concerns when these drugs are used with TB treatment. Women in childbearing age, we need to be cautious and provide effective contraception. Risk-benefit has to be compared to other options and to be considered, and women have the right to make the informed choices. We have seen an unprecedented rollout in low-income countries, but uncertainties remain. Implementation challenges and cost in middle-income countries have to be solved in order to make it happen for everybody. So in my vision, integrase inhibitor-based therapy will help us to succeed in our goals, and I hope so that we will see finally the end of the AIDS epidemic. I thank you very much.
To introduce our next plenary speaker, please welcome back Her Excellency Sandra Granger.
Pedro, thank you. That was great. ARVs have helped us to achieve so much in reducing new infections. We wait with impatience to see how the next era of ARVs will improve the quality of life for those living with HIV. ARVs alone are not enough, though, in reducing new infections, and there's a critical need to look into differentiated models of prevention to reduce new infections. Please join me in welcoming to the lectern someone who has been in the battle against HIV for 15 years and in public health for over 20. I invite you to welcome Dr. Nduku Kilonzo, Chief Executive Officer of the Kenya National AIDS Control Council.
I would like to start by acknowledging and thanking Her Excellency the First Lady of the Republic of Kenya, Mrs. Margaret Kenyatta, who is here, our Chief Administrative Secretary in the Ministry of Health, my Chair of the Board of the National AIDS Control Council, and Team Kenya at large, many of us in this room, Parliament, Senators who are here, my friends, colleagues, and my very special parents, Monica and Pascal Kilonzo. I want to take this opportunity to welcome you all to the Kenya session. Some are already done, but some are remaining. Please pass by the Kenya stand to see what we are doing. It is stand 112. I have no disclosures and no conflict of interest. My presentation is going to focus on trying to look at where we are coming from as far as HIV prevention is concerned, where we are at now, what lessons we have learned, and where we need to go. I will change gears a bit from the discussion this morning and really focus on what we need to do at implementation level and how we take the science that we have from the global level and bring it down into policy and practice and implementation. Let me go back a little bit. When I was asked to talk about differentiated models of HIV prevention, I reflected on what the expectations would be for a while, and three important perspectives came to me. I want to start with the first, is that we have very, very many options for HIV prevention that have been delivered over time. Started in the 80s and the 90s with harm reduction and data and evidence for behavior change. We remember the case of Uganda and condom use. We then moved on to around the 90s where we had data on male and female condoms, post-exposure prophylaxis, and we had data on treatment that was not always consistent, STI treatment that was not always consistent, and testing and counseling that really focused on where we saw the best benefits and protective effects on couples as well as those who tested HIV positive. In the 90s, in the 2000s, we had male circumcision, treatment as prevention, and now increasingly talking about oral exposure prophylaxis. We've just heard about vaccines this morning in a very interesting lecture. But I think we also need to think about, as we are developing vaccines, the questions around vaginal rings, antibodies, and long-acting injectable ARVs. All this provides us with a huge toolkit for being able to deliver HIV prevention. However, we need to recognize that the most important issue or factor in differentiation and a differentiated approach is going to be access to services, is going to be availability of services, is going to be coverage of services, because you cannot differentiate and deliver where services are not available. I want to think and take us back to the questions around going beyond the biomedical interventions in HIV prevention. We know that we have studies that have looked at economic empowerment, that have looked at community empowerment, that have looked at education for girls and young women, harm reduction policies. There is evidence for these interventions, but they have rarely and often not been implemented at scale, and neither have we put sufficient resources to it. One of the issues that we consistently hear, and I've had in these sessions over the last few days, is that stigma is a key issue that drives HIV and AIDS. And as one of my colleagues from Kenya said yesterday, stigma kills. Yet, that is not where we make our most significant investments. Looking back at when HIV prevention was the only option and treatment was not available at large or was not affordable, the global community pulled together for prevention. Civil society in particular really pushed the boundaries, and I'm reminded of the opening plenary where Dorothy Onyango from Kenya represented that voice. The global community coalesced, and we had a lot of research and resources. Governments took ownership and leadership, and communities mobilized for services and advocacy. New infections were reduced drastically. I reflect on this because this becomes very important as we start to talk about perhaps what we have not done as well as we should. There were single-purpose vehicles created, there was funding mechanisms, there was alliances, there was data, and there was research. So where are we at now as far as HIV prevention is concerned? I want to start by daring to say that we have a HIV prevention crisis. And this is my second and very important reflection on differentiation. We have many successes, many that have been spoken about so far. But we also know that for the last almost decade, we have consistently had almost 1.8 million new infections every year across the world. If you translate that roughly, it comes down to about 5,000 new infections. So as we sit here by the end of today, we shall have 5,000 new infections across the global community. As Professor Daibo said during the JLI session, if we have too many new infections, and in the very near coming future, we cannot afford treatment, or there are no resources to keep on treatment, the resurgence of an HIV epidemic is not an impossibility. Whereas this is a very general line, I think I want to say that there is underlying data that we need to look at because we have a differentiated epidemic. If you look at where we have had the highest numbers, there's a growing epidemic in some parts of the world. I want to talk about specifically Eastern Europe and Central Asia. Although we have a few absolute numbers in terms of new infections, there is an increase year to year. In particular, key populations have significant increases, and these are the only places where we have increases in HIV new infections. Most of the countries do not have injecting drug use do not have harm reduction programs. But I want to move on and talk about the next place where we also have challenges, is Africa. We have seen a small decline in the numbers of new infections annually. However, Africa and Sub-Saharan Africa in particular has the highest burden of HIV and AIDS, contributed about 65% of the new infections in 2017. With a population growth that is significant and very high, expected to double over the next 10 years, with the future of HIV comorbidities, including non-communicable diseases and TB. What this means is that we will continue, if we just keep the same rates of new infections, we will double the numbers every year just by the number of new infections. It is important to think about the demographics of HIV if we want to invest in prevention, because the rates of new infections, and especially among adolescents and young people. This graph here tries to look at it just shows bubbles from across the globe in terms of new infections among young women aged 15 to 24 years of age. If you look at Africa, Western and Central Africa, Eastern and Sub-Saharan Africa, you see the highest numbers of new infections. These are driven in many issues and in many cases by factors that sit outside of the health sector: gender inequality, sexual violence, and many that have been talked about in this conference. I think it is important to note that the elimination of mother-to-child transmission programs that we have focused on and are all investing in and have been identified as a priority for HIV prevention globally, are not going to be achieved and sustained if we continue to have new infections. In effect, they are getting wiped out within 2 decades. So, in thinking about where we want to go, in 2016, we had a high-level political meeting, and there was a commitment that we would get to less than 500,000 new infections by the year 2020. In 2017, we had 1.7 million new infections. Now, the pathway that we have to get there, which shows us that we don't have sufficiently a virally suppressed number of people, condoms available, young women not having sufficient knowledge, countries, the coverage for services, whether it's circumcision, PrEP, populations that have been left behind, and declining resources, means that we shall perhaps have a glass ceiling. I have tried to put it there in the form of a ceiling that is supposed to be not very visible, yet visible. So what do we need to do differently? I paint this bleak picture, not to say that we haven't made progress, but to say that we have to rethink and get back to delivering HIV primary prevention. What lessons have we learned from the past? In 2014, there was a UNAIDS Lancet Commission, many of the authors are in this room, that told us that a biomedical response aimed at rapidly scaling up testing and treatment is essential, and it remains essential and will remain essential, but in itself will not be sufficient to control the epidemic. It talked about lack of political leadership to invest in prevention. It talked about perhaps a lack of business-style prevention management, and it talked about challenges in delivering services to the underserved and priority populations. And I dare say it is perhaps true that primary prevention is complicated, it is difficult to measure, and often goes into areas that are not in the health sector. However, we must address the structural barriers if we are going to get to where we want to go. And let's remember we have had significant successes. The voluntary medical male circumcision program started slow. It focused and invested heavily on community empowerment and buy-in, noting that circumcision is usually a cultural issue. They tested campaigns systematically over time. Global and country roadmaps, in-country roadmaps were developed with clear targets, and services were implemented at scale. And today, for instance, last year, we averted 230,000 new infections globally. In Kenya, in particular, we've made significant progress from the slow start because of the focus on buy-in and community leadership. And that is what we need to be thinking about for prevention. Looking at treatment and treatment for prevention, HPTN 052 showed us the protective effects of almost 96%. These results were and remain key in propelling us forward. The challenges we have to recognize include the fact that over 14 million people who are HIV infected are not yet on treatment. We also know that data tells us in the real world setting, we have the effects of 96% may not actually be realized within the speed that needed to be. Modeling from UNAIDS and from UNICEF showed us that where we have, and phylogenetics showed us that we have the highest numbers of new infections during the acute HIV infection period. This is also the period where most people do not know their HIV status. The 90-90-90 and scale-up of treatment has its biggest challenge in the first 90, which is being able to find people who are HIV infected and diagnose them and put them on treatment. And therefore, it is important to recognize that treatment is essential. It must be continued to scale, delivered with quality, but it will not get us the prevention benefits we need immediately, now, quickly enough. It worries me sometimes, before I move on from this slide, that we tend to have a false dichotomy between treatment and prevention. We sometimes talk as if they are two disparate efforts, yet they are the same side. They are two different sides of the same coin, and that is the HIV prevention, the HIV response. We have one epidemic and one only, one that we have to continue to invest in prevention and one that we have to continue to invest in treatment. So having talked about the lessons that we have learned, what we must continue to do, I want then to reflect on really my third and important point, which is coming back to the third perspective on differentiated models for HIV prevention. I want to draw my experience from Kenya, and I fall back on our HIV prevention revolution, where the notion of differentiated approach to the HIV response actually began. Informed by recognizing that we needed to do things differently. We realized that the one-size-fits-all approach for HIV prevention was not working for us. We realized that we needed to be able to think about accountability for HIV prevention. Let me give a very specific example. When you think about you go into a country and you ask, who do we ask if we don't meet the ART targets? In terms of a designated official, you will probably get a very clear answer. There will be someone in the Ministry of Health who is responsible. When you ask the same question and you say, who should we ask if we do not get if we do not get the numbers we want for young people's new infections? Is it social services? Is it the HIV sector? Is it the HIV response and Ministry of Health? Is it the reproductive health in the Ministry of Health? Or is it the education sector? And it is that multi-sector approach and the need to ensure that we have accountability for HIV prevention that is essential. We recognize that we also must have deliberate decisions to finance treatment and prevention, and therefore develop the idea and the notion to start to use our data. And that brings me to the first element of a differentiated model for HIV prevention. In 2013, we took on to build the capacity for data management, modeling, and epidemiologic monitoring in country, in Kenya. With the support of partners, we build data and we build capacity for modeling. Granulating our national epidemic by county, Kenya is made up of 47 counties. which have different risks, different epidemics. And the graph on your left, which is a map of Kenya, shows you prevalence in 2013 that was by the different counties, which ranged from as high as 20% to as low as 3%, with some counties having as high as more than 10,000 new infections and some having as low as 400-500 new infections. However, between 2013 and 2015, we had an overall reduction in new infections, but we had varied progress. And we asked ourselves, why is it that some counties that have low incidence or low new infections in 2013 seemed to even double or triple the rates of new infections? And this is where granulation and beginning to think about differentiation really started to take effect. If you look at the reds, which is on your right, the map on your right, we realized very quickly that infrastructure was a significant factor in the numbers of new infections across the counties. When we did heat maps for those areas, we saw that the new infections were hottest across and followed the transport corridors that were under development. We also realized that with new incoming resources in counties, and the border towns became quite red very quickly, meaning they had high numbers of new infections. And it is asking ourselves these questions that allowed us then to move to the second aspect of differentiation that every country needs to adopt. And this is developing negotiated or targets for national and subnational levels. We started to look at, so if we are going to have prevention, should we have national targets for prevention, or should we have county-based targets, that is granulating the data and then developing targets and being able to say for each county, and I have taken just a few counties on alphabetical order, starting with Baringo and moving down. We looked at what is the total number of new infections that year and where should we be by 2020 if we are going to get to our goal of less than 75% new infections. And we looked at that across the different age groups. So essentially, the two things that we learned is that for us to be able to apply a differentiated care prevention model, we had to be able to look at negotiating with the holders and duty bearers for service delivery and prevention in the county level. And the second, routine data reviews based on county-specific data became what we used and continues to be used for monitoring to show progress. The third element was being able to look at the extent to which we could leverage beyond service delivery and numbers. In this case, I'm talking about leadership and political will. We had the Beyond Zero that was pioneered and championed by Our Excellency, and we then also had government policy with the review of maternal policy and making maternity services free. We began to create a culture of accountability because there were numbers and targets and indicators that had to be measured across the different counties. And we began to see a lot of technical action with everybody saying, I have a target to meet. It mobilized political action and it mobilized resources. If we start to think and continue to think about where we need to go, we believe that this has been key in us being able to get to the details and to get where we are in 2018. This is a picture of 2018 versus 2013 that I showed earlier, where you can see that you have many more counties reducing their numbers of infections than we had in 2013 and also in 2015. But what about service delivery and being able to deliver services at scale? I borrowed this I adapted it from the HIV epidemiology annual report, and this is the story of San Francisco. We know that by applying services consistently at scale, targeted to those that needed them most, whether it was key populations, we have seen a significant decline in number of new infections in a city such as San Francisco. But going back to basics, is that we have also seen that sometimes we have deserted what works. The story of condoms. Condoms are cost effective and we know that they work. The biggest challenge for treatment today is the first 90. In the early days of testing and counseling, and I refer back to the beginning of my presentation, where I started talking about where we are coming from. we had Know Your Status campaigns, and we had community testing and counseling. We had people and community-led action going out and reaching the most underserved to bring them for VCT services designed to be stigma-free and non-judgmental. Many of them there were still challenges, but there was a significant uptake of treatment and a significant uptake of testing. Community-based action is one of those areas where in the early days we had most countries having mechanisms for some social engagements and contracting of communities, deliberate community engagements through community-led interventions. Importantly, the understanding that countries have capacity and know what works, and therefore can be able to develop and deliver the interventions that are required. Talking about condoms, I want to remind us that leaving what works behind. There are several aspects of condoms that we need to think about. Condom supply and commodity security, demand and access, monitoring, tracking, and evaluation. We have less than 50% of the condom need. We did, again, targets for the number of condoms and the number of condoms per man per year. It is important for us to go back to that discussion, to go back to those investments, because we know if we continue the investments, we can have a cost-effective way of being able to deliver HIV prevention. Whereas we have made a lot of progress in the numbers and the targets, whereas we have made a lot of progress in the services that we offer, we have also reduced investments in HIV prevention. This is a graph that comes from the Global Fund looking at the total investments in HIV prevention against the total investments of the Global Fund. And I think what we realize is that the investments in HIV prevention have continued to be lowered globally and currently account for about 2%, have primary prevention has accounted for a significantly small number or small percentage of the resources that we have. We will not be able to reduce our new infections if we are not investing sufficiently. How can we invest sufficiently? I want to refer us to the HIV Prevention 2020 roadmap. And for me, this is the guidance for delivering a differentiated model for HIV prevention. It is a 10-point action plan that is delivered and is being implemented in 25 coalition countries. It looks at the key things that must be done to deliver HIV prevention at scale. One is we must set targets, we must have institutional accountability. We must think about addressing barriers, both policy barriers and legal barriers, whether it is barriers related to adolescents and young people or related to key populations. But to enable services to be available, we must think about strengthening social contracting, and we must have HIV prevention services because we often don't have a delivery package for HIV prevention services. In 2016, in the political declaration, we developed global targets. We have, at Impact, we want to have less than 500,000 new infections by 2020. I painted a gloomy picture, but all is not lost. We have program-based targets that focus on populations. We have outputs that have been determined that we all must work towards. But importantly, we have targets for sustainability and financing. We shall not deliver HIV prevention without the financing that we require. We must ensure that we allocate resources to HIV prevention budgets. But importantly, we must also ensure that there are services that are within and provided by communities at community levels. Yesterday in a session in Kenya, one of the panelists told us that the one thing that we must invest in is community health workers, community-led services, and communities. So as I part, I want to just say that reinvigorating HIV prevention, primary prevention, and delivering differentiated models of HIV prevention is going to require that we actually do have granulated data across our different counties and countries. It requires that we have targets and accountability. It requires that our enabling policy environment and that we have a commitment to equity, to to equality, and to human rights. It requires that we have the political will, and sometimes I always ask, what is political will? It is an intangible item in the context of programming, in the context of service delivery, but it is essential as a software that allows us to be able to deliver. In many sessions and in very many discussions over the last few days, what we have heard is that where there is political will, we see results. Where there is no political will, we may not have, and we don't always see the results. And therefore, we have to figure out how we invest and also facilitate, as Michelle said yesterday, making political choices that allow us to move forward. And we must invest in results, and we must invest funds. All this with accountability, commitment, focus, synergies, innovation, and scale. Services at scale is what will give us the prevention that we need. I want to acknowledge my colleagues who helped me put this presentation together. Many of you who read this presentation gave me slides. Thank you all very much. Asanteni.
The conference organisers would like to thank all the speakers and co-chairs for their participation. The plenary session is now over. We wish you all an excellent day at the AIDS 2018 conference. As you leave the room, please remember to return your headsets at the door or give them to one of our volunteers. Thank you for your cooperation.